Let us now look at how to find the angle between a line and a plane. So in this diagram, I have this plane, this green thing is the plane, and I have a line here. The line is pointing in the direction of V bar, right? So basically I can say the question is, how do I find the angle between V bar? Because line is pointing towards V bar, the question is how to find the angle between V bar and this plane, right? This plane has a normal N bar, right? It's very evident from the diagram that this is a 90-degree angle. If I can find this angle, theta, then this will be 90 minus theta, right? And I'm naming this 90 minus theta as phi. So basically, if my plane is like this and the line is like this phi is what I'm looking for. I'm looking for the angle between the line and the plane. But I can't directly get phi. So what I will do is I'll get this theta and I'll subtract theta from 90 degree and that will be my phi, right? So how do you get this? So these are two vectors. One vector is n bar, the other vector is v bar. How do you find the angle between them? You use the cos theta formula, right? You use the cos theta formula. So I've done that. Now your phi is 90 minus theta, right? So what I've done is I've taken sine on both sides. This is sine phi is equals to sine 90 minus theta, right? Sine 90 minus theta is cos theta. So sine phi is equal to cos theta is what I got. Cos theta is something that is already available from here, so I'll put that here. So sine phi is what I have. Now phi is equal to sine inverse this. So this is the angle that I'm looking for. So this is the angle, or I can say this is the required angle. So whenever you're asked to find the angle between the line and a plane, what you do is you find the angle between the line and the plane's normal first of all. Once you get that angle, then you subtract that angle from 90 degree because that will be the angle between the line and the plane. So this theta is not your final answer. Remember, your final answer is phi. So you are supposed to get this. So this was the formula, or this was the concept that was to be used. And from this you can also get the conditions, like when is a line parallel to plane, or when does it lie along the plane. It lies along the plane when your phi is 0. So if your b dot n is equal to 0, if your b dot n equal to 0, that would mean that your normal and the line are perpendicular to each other, and then I can say the line is parallel, right? If your b dot n is equals to 1, or I can say if your b is equal to lambda n, that's better to say. So if your b is equal to lambda n, that means if your b, so your n was like this, and if your b is also pointing in the same direction, so n and b can be related by some lambda. In that case, that line would be perpendicular to the plane, right? It would be parallel to the normal, but it would be perpendicular to the plane. So this is the condition for perpendicularity here. This is the condition for perpendicularity, and this is the condition for parallelism. So only if this condition is obeyed, your line will be parallel to the plane, and only if this condition is obeyed, your line will be perpendicular to the plane. So with this, the angle between a line and a plane topic is done. Let's move on to the next subtopic.